Over winter break, I discovered this competition called Halite II, and basically the premise of this competition is you program an artificial intelligence to play a game for you. Basically, you have a fleet of ships, and you try to colonize these planets here. And as your ships colonize planets, they produce more ships. Your goal is to colonize all the planets, or kill all of your enemy ships. Of course, there's like rules and intricacies to the game that the bot has to follow, but that's essentially what the game is. You can see here an entire match being played out. You upload your bot, and they will automatically matchmake you with your rank and set you on a rank of, I think, how many players? 4,563 players. Each player has their own, I guess, level. And in my level, which is high school, I have managed to get within the top 25 in 3 days, actually. With my peak rank being 250, I think. So, starting with the starter bot, I decided to build on top of that. Basically what the starter bot did was it took your ships, right here, and sent them to the nearest, or not even the nearest, the first planet in the list of planets, which always happens to be this one for you and this one for the enemy. And if a planet was colonized, it would send them to the next planet. Now this is a super passive algorithm and doesn't really help much. So what I decided to do was, instead of sending them to the first planet in the entire list, do a k-nearest neighbors algorithm and find the 3 nearest planets to them and send them to the one with the smallest radius and thus the fastest production speed. So in this case it would still happen to be this planet, but say there was a smaller planet up here, I would send my ships to there and it would start production much faster. And this bot was all done in Python because the competition seems to have a lot more support for Python. So I just decided to do it in Python. Figured it'd be easier. And I went through this iteration of the algorithm and it worked. It got me up places after a couple bug fixing, except it was still a very passive algorithm. So what I actually did was, once I had controlled all of these planets, so let's say I controlled this one, this one, this one, this one, this one, and this one, and say the enemy had controlled all the rest of them, what I would do is I would begin sending my ships to the enemy planets and start taking over their planets and attacking them. This was a basic form of regression, so basically I would send every new planet to the nearest, using the k-nearest neighbors algorithm again, I'd send them to the nearest enemy planet the ship was close to and have them start attacking the planet and attempt to take it over. And that really worked. This particular algorithm, in theory, would have gotten me under 1,000, rank 1,000. And I say in theory because there is a rule in this game. And essentially what it is you have 2 seconds to calculate your ship's moves, I guess, before every turn starts. And eventually, after roughly 70 iterations of the game, my algorithm would have to be calculating so many k-nearest neighbors across a massive data set, and it would take more than 2 seconds to do using Python and pandas. So I decided to switch to a faster language and went from Python to C#. And that's when I created the bot CC. Now, CC was never really implemented and never really improved upon. Actually, most of the code is just the basic bot code, because I was thinking about how to future-proof this new bot, and I realized that, one, I needed a new pathfinding algorithm, so I would have to eventually implement a star instead of using the default pathfinding algorithm. Two, I would want it to be a genetic algorithm. Well, I would first of all want to split my fleet into roles, so I could basically define what each ship would be doing. I could have a military and a workforce separately. And then I would also need to have the proportion of those roles be genetic, sorry. And that basically just means that instead of manually finding the proportion across a ton of tests, I would program a genetic algorithm to find the role proportion for me. So basically the bot would get better as it did better. And I was looking at all this and I realized that I wasn't really 100% comfortable using C and Python to the point where I could create something like a genetic algorithm with them and implement A# and implement roles without having to spend a lot of time learning new things. So I decided to instead change to Java, which is the language I have the most experience with and I'm the most comfortable using. So this gave birth to a bot named Jabbery. So what Jabbery basically did, was he implemented, or attempted to implement, a more advanced version of my original bot, whose name was Plembleton. So I basically just ported Plembleton to Java and added a couple extra things. I made it be a lot more aggressive, so not only would it attack other planets, but it would attack other ships, and some other minor changes like that, and uploaded it. And this bot got me to over rank 600, I believe. And it wasn't timing out. It was pretty much the same algorithm as Plembleton, and it wasn't timing out, which was good. So I began to optimize Jabri for those features I wanted earlier, these features, and I realized that I would have to build an AI from scratch as I was planning it out. So I scrapped Jabri after 2 versions and created the current iteration of my bots named Jabril. So what Jabril does is I managed to get role designation based off of a dynamic proportion. So what that means is I have 3 roles. I have the workers, whose sole job is to colonize. I have the attackers, whose sole job is to basically attack other ships. And I have a 3rd role that I'm planning, I haven't implemented it yet, called the kamikazes. And basically what they are is they literally suicide into enemy planets and blow the planet up, because you can do that. And it does what a kamikaze does. It would kill a lot of their fleet at the sacrifice of one of my ships. Have not implemented this yet, but the framework to implement is there. I just have to program the algorithm to do it. And I mentioned that these proportions were dynamic. So basically you have 3 variables, W, A, and K, and you set these, so like if you wanted a 2 to 1 to 1 proportion, you'd set these variables to like that, and the program would take these variables and generate, or assign the roles to the fleet in that proportion. And what this does is prepares it for a genetic algorithm where the separate genetic program can optimize Jabril without me having to go in and manually change these variables or change the hard-coded proportion. Therefore, it's dynamic. I also added an a primitive A# algorithm. There still are a couple bugs, so it's not fully implemented into Jabril yet at this stage. I've only had 3 days to work on this. But A# exists in it, and I use it for some of the navigation things, not all of them, because, again, there are bugs, or not A*, A*, and that's pretty much that for A*. And I've just begun to program the genetic algorithm. So far, I've been optimizing this ratio manually. The current ratio right now is, I think, 5 to 1 to 1. And currently all the kamikazes are using the attacker algorithm, so it's really a 5 to 2 ratio. And that's just kind of what I've done manually. But the genetic algorithm, which I am kind of halfway done programming, will test this against other bots with a customized fitness algorithm that I created, and basically optimize these proportions. And that's what's in plan for Jabril. Now, Jabril, so far, in its half-done state, I've uploaded it just to see how well it would do, and this is the bot that got me to a peak rank of around 250. I think I'm sitting at like 275 right now after a couple tweaks, but this got me into 250 and into the top 25 high schoolers who play this game. So now I guess I'll show you the algorithm, and all of this entire directory is uploaded to GitHub, which I will link probably in a PDF along with this video, or maybe in the description. So originally we started out with Plembleton over here. Hold on. Change the scene. Plembleton. Alright, originally we started out with Plembleton, and basically it's pretty simple algorithm. 82 lines. Again, does exactly as it was described before. I programmed this using Python in PyCharm. And the thing about pandas is all the data structures were panda arrays and dictionaries and lists, and Python being Python isn't really too efficient with that, so I changed over to C. And this is even simpler. I didn't really edit a lot of the code, but it exists and it is in the repository, although it's not really worth looking at because I ported it all to Java. Now, in Java, I started with Jabri. This is really the first time I kind of made it my algorithm instead of the basic algorithm. I guess I'll just go through kind of what it does. It starts a new ship, gets its docking status, which is if it's on a planet or not, skips it if it's on a planet, and selects the K nearest neighbors, as I said earlier. And there's a couple little bug fixes, and a really, really bad code. I was doing this at 3 a.m., and I just kind of wasn't thinking. And this is a primitive version of my role designation. All of the ships kind of change roles and it was super inefficient, but it got me enough, and you can see I kind of started a more specialized role designation down here before I realized I needed to build this robot from ground up. That gave rise to Jabari here. Jabril, rather. We just looked at Jabari. So Jabril currently not even on version 1 because it's not done yet, even though it is playing for me right now. These are the ratios up here. Again, I've been manually editing them, but once I finish the genetic algorithm, I'll have them take them out of a config file, or that's for C, rather a properties file. This is in Java. Yeah. So what I did was I created a turn function. Now, if the ship isn't designated in a role, I add the ship to a list, and according to the proportions, and then if it is designated to a role, I then iterate through the different lists and send them the appropriate commands, and that's how this algorithm basically works. It's a combination of a lot of different algorithms. And as you can see here, this method is just attack. 333 lines, and took me an entire day to code, but it's gotten me very, very far, again, into the top 25 high schoolers. This is my attempted A-star implementation. I'm really just using hash maps to map out the G value and the heuristic costs and everything, and it's it's got a couple bugs, but for the most part it is functional. Sometimes it gets stuck in this sometimes it gets stuck in this while loop because the only way to break it is this return statement, and I have yet to figure out why it gets stuck, but sometimes it gets stuck. Specialized algorithm for calculating the G-score and the heuristic costs, and if a specific node is occupied, and to reconstruct the path. And I had to create a custom object for storing all of the, coordinates in order to more efficiently calculate out the path that a certain ship should take to get to a certain target. Yeah, that's pretty much it for Halite 2. It's pretty cool. And yeah, I'll link the entire repository, the entire GitHub repository to, oh no, I think this guy put in a new robot or something. I used to beat him all the time. Oh well, I'll link the GitHub repository to the description or elsewhere. But yeah, that's pretty much it for Halite 2.